So scientists, they use a specific way to analyze problems and do problem solving. So specifically, we use the scientific method, which is a way of learning that emphasizes observations and experimentation to understand the world. So there are four key characteristics for a scientific method: observation and formulation of a hypothesis, and then we'll test the hypothesis by designing different experiments. After experiments, you form the conclusion that give us the formulation of laws and theories we learn nowadays. So now, for example, if we look at the everyday application for scientific method thinking, for example, let's say that yesterday you went to visit your friend, and soon after you arrived, your eyes start to itchy, and then you start to sneeze, and you observe that your friend has a new cat. So this is observations. So in a lab, the observations including, the measurements you do, the data you collect, and the experimental observations you see, like color change or precipitation formation. Those are all part of observations. So that once you have this observation, you come with a hypothesis where maybe you're allergic to cats. So how do we know if our hypothesis is correct? So we do experiments, right? To test your hypothesis, you leave your friend home. And now this experiment will leave you a conclusion. So if the itching and sneezing stop, and maybe your hypothesis is correct. So if the itching and sneezing do not stop, and maybe your hypothesis is wrong, and you might have a cold. So this process we use every day is what we call scientific method thinking. Most of the time, to prove or disprove our hypothesis, we need to design several experiments to get consistent conclusion. Now, to prove your hypothesis, and then you want to do an experiment. So you visit another friend with a cat, and then turned out to be you begin to sneeze again, further supporting your hypothesis. So this is experiment 2. And you come to a second conclusion, and the experimental results show that you are allergic to cats. So this shows it's very, very likely that you're allergic to cats, right? So we start with the maker observation, then we form a hypothesis, then we design experiments, we draw a conclusion. So the hypothesis is usually modified if the results of the experiments do not support it, right? So based on several experiments, we keep modifying our hypothesis until we come to basically the definition, the theory that we show is correct, that explains our hypothesis. So observations involve measuring and observing some aspect of nature. So it could be color change, measuring data in the lab. You could be measuring the volume, the mass, or observing color change for a chemical reaction. So those are all observations. And then you have hypothesis is a tentative explanation of observations that's made. And then based on the hypothesis, we can test our hypothesis by experiments. So those are highly controlled observations and designed to validate or invalidate the hypothesis. So once you have the experiments, you come to a conclusion. So a scientific theory, they are formed by one or more well-established hypotheses that give a deeper explanation for such underlying causes for observations and laws. So theories, they are hypotheses, so they can be tested and retested and validated by experiments. While a scientific law basically summarizes the results for a large number of observations. So when you see something happens all the time, you have a large database, and then you can actually observe it. So those are what we call laws. So laws are observations, and theories, they are hypotheses that can be proved and disproved. So for example, the law of conservation of matter states that in a chemical reaction, matter is neither created or destroyed. So this is a law that's summarized based on a large number of observations. There are many, many chemical reactions. It has shown that the matter is always conserved before and after chemical reaction, which leads to this law. So now let's look at an example. For each of the following, indicate whether the steps of the scientific method being described as observation, hypothesis, experiment, or conclusion. So A, a blender does not work when plugged in. So this is what we visually observe. So it's observation. The blender motor is broken. So this is one of the hypotheses we come up with. So this is a hypothesis. C, the plug has malfunctioned. So this is also a hypothesis which could lead to the observation we see. D, the blender does not work when plugged into a different outlet. So this is experiment where you can test and see if your hypothesis is correct or not. And E, the blender needs repair. So this is a conclusion where you test out the hypothesis show experiments show that the blender is broken. So the blender needs repair. This is a conclusion. So overall, when we look at a scientific method, your starting point is observation. Based on the observation, we form hypothesis. Okay, so a large set of observations becomes laws. Okay, and when you have a hypothesis, we'll design experiments and tests to prove or disprove the hypothesis. Once the experiments come to a conclusion, and that's when we form theories. So theories, they are hypotheses. So they can be proved or disproved. That's why some of the theory we learned about 50 years ago may be correct, but now has proven not incorrect. So theories can be proved or disproved by experiments. Now let's look at another example. Classify each statement as an observation, a law, or a theory. So A, when the metal is burned in a closed container, the mass of the container and a constant does not change. So this is an observation where you can visually see. B, matter is made of atoms. Okay, so matter is made of atoms. This is basically a theory. So it's a hypothesis because we cannot visually observe it. Matter is conserved in chemical reactions. So this is a law that's summarized by a large amount of observations. D, when wood is burned in a closed container, its mass does not change. So this is an observation.